Alright, so let's finish this last example with the rationals. Got all this information done. Remember, factor, get the vertical asymptotes and the x-intercepts, factors from the denominator, give you the vertical asymptotes, factors from the numerator, tell you the x-intercepts, plug in 0, that gives you the y-intercept. Then to find either the horizontal or the slant, you compare the degrees. When the degrees are the same, you just look at the ratio of coefficients. If the bottom bigger, the answer would be y equals 0. Here the top was bigger, so I went ahead and did the division. It's just the quotient part of the division that you need. Now, if you want to do synthetic division also, you could. Let's refresh that really quickly. Synthetic division, you just need the numbers, right? So the coefficients of the numerator, I have 1, 2, 0. Those are the coefficients from the dividend. And then, be careful, you wouldn't end up using -1, right? X minus 1 is the factor, but when you're doing synthetic division, you're working with the numbers, not the factors. So the intercept that corresponds to this factor is 1, right? Don't put -1. You need the intercept, the number, not the factor. All right, so synthetic division, the first thing is this first column just copies down. So 1, copy it down. Then you're going to multiply 1 times 1. You're going to put that number in the next column, and then you're going to add down the column. So you multiply, and then you add. Multiply, and then you add. And then that last number is the remainder, right? That's the remainder. This would be your constant, your x to the 0 term. This would be your linear term. If you had more terms in the synthetic division, you kind of build yourself back up in terms of x's. But here it ends up telling you you got y equals 1x. And then you have the positive 3. So you should get the same thing whether you do the long division or whether you do synthetic. Now you can only do synthetic division. Since this is a linear divisor, you can do synthetic. If this would have been x squared minus 1, couldn't do synthetic, you would have to do the long division. Okay, anyways, let's get this graphed and then we'll move on to the next stuff. So the critical features, I've got the vertical asymptote at 1. I've got the slant asymptote at x plus 3. More or less looks like that. Doesn't have to be super precise. X-intercepts at 0, and then at -2. Both of those multiplicities are 1, right? Multiplicity of 1, it's not repeated. Multiplicity of 1, not repeated. So the graph is going to cross at both of those. And then we kind of just need to figure out what is it doing in the rest of the area. So let's test a point. Like if I plugged in something like -1, if I were to plug it in, you'd have 1 minus 2. So if I plugged in x equals -1, let's see, you'd have 1 minus 2 on the top, and then -1 minus 1 is -2 on the bottom. So here you'd end up with a positive 1/2. So all you really need to know is whether that point is above or below. So I know the graph's going to look like this. Then logically you can kind of just tell, since the graph has an odd multiplicity, it's going to cross, head down towards the asymptote, and then here it's going to cross, head over towards the asymptote. And then once again, I'm either going to be up above the slant or down below the slant. But if your graph was down below, you would have another x-intercept. That can't be possible since I don't have any other factors. So you know for sure the graph is going to have to instead be above. Again, it doesn't have to be super precise, but it should be pretty close. Okay, hold on just a minute while I switch it over. Okay, kind of shifting gears a little bit to these next ones, these inequalities. We're going to end up solving with something called a sign chart. And this is maybe a little bit weird for you, but you probably did something similar to it in Precal. But anyways, as you practice and as you go through the notes, hopefully it's going to make the homework questions make sense. So let's look at this first one. I don't think I can zoom in anymore, can I? Nope. Okay. Oh well. All right. First thing you would always want to do is, if everything is on different sides, so you've got stuff on the left and stuff on the right, first thing you'd want to do is get everything on one side, right? Get a 0 on one side, everything else on the other. Here, it's nice. All the important terms are on the left, and then it's just a 0. So that's good. That would be the first thing you have to do, but it's already done for me. The second thing would be to factor, right? So let us factor this one. Here it's going to be 5x plus 1. And then I think it's going to have to be a 3x minus 2. So factor, remember, always check to see if you factored it correctly. Just multiply it back together. 5x times 3x, yep, that gives me the 15x squared. Then that's negative 10, and then a 3, so negative 10x plus 3x, negative 10 plus 3, that would combine to give you the negative 7, which is correct. Then the 1 and the negative 2, yes, that's good, right? So always, always, always check to make sure you factored it correctly, because if you don't, the whole rest of the question is going to be wrong. All right, the next thing is to find the critical values. So I would find the x-intercepts. So I'd take all the factors, set them equal to 0, find the x-intercepts. Or later on, when we have a rational, you'd want to find where the asymptotes are also, the vertical asymptotes. But basically, from each little chunk, from each factor, we're going to find the special x value that corresponds to it. Set this factor equal to 0, and you'll end up getting negative 1/5. Set this factor equal to 0, and you'll end up getting 2/3. So get it factor, then find all those special values, and then what we're going to do is make a number line and throw those special values on my number line. Right here I only had 2 factors, so that's going to split up this number line into 3 chunks. Now remember, this is a polynomial. If I were to actually plug in 2/3, right? If I were to plug in 2/3 either to here or into the factored version, it's going to end up giving you out 0. It's an x-intercept. When you plug it in, it's going to give you out 0. That's why it's a factor or a solution or a root. X-intercepts give you out 0. This one, if you were to plug it in here, would also give you out 0. So then we just need to test these other intervals. I've got that right interval, the one in the middle, and then this one on the left. I'm going to pick a test point for each interval. I'm going to plug in. You could plug in either to the factored version or into this non-factored version. And we need to figure out whether I get a positive output or a negative output, right? Because we want to know, when is this parabola, right? This is a parabola. Greater than 0 means positive. So if I were to graph it, I would want to know, where is this graph above the x-axis? Where is it positive? So we find this number line, put the special values on the number line, then we're going to test the little sub-intervals. So let's go ahead and move forward with this one. I need a test point that represents this rightmost interval. 1 would be a pretty good test point. So let's try like x equals 1. You could plug it in to the non-factored version, but I think it's a little bit easier to use the factored version. So let's think about it. If I plugged in 1, 5 times 1 would be 5. 5 plus 1 would be 6. I don't really care that it's a 6. All you need to know that if I plugged in 1, this left chunk would be a positive number. If I plugged in 1, 3 times 1 would be 3. 3 minus 2 would be 1. That's also positive. Right? So I don't really care what the size of the number is. I just want to know if that number as a result is going to be a positive or negative. Plugging in 1 as a test point for this interval, you could plug in 3 or you could plug in 17 million. It would be the same thing. Any x value from this interval would give you a positive for this chunk and would also give you a positive for this chunk. And if you have 2 positive chunks multiplied, that means overall that chunk is going to produce a positive output. So the left chunk is positive, the right chunk is positive. Positive times a positive means overall that result is going to be positive. And again, that test point didn't really matter. You could pick anything that's bigger than 2/3, but pick something that's pretty convenient for you. Here in this next interval, you could pick something like 1/80, but I think 0 may be a little bit easier to test, right? You can pick any number between these 2 special values, but pick something that's convenient for you. I'm going to test 0 because I think that's pretty easy. 5 times 0 plus 1, so this left chunk is still positive, but 3 times 0 minus 2, that would be negative. 3 times 0 is 0, 0 minus 2 is negative. So this chunk is positive, the chunk on the right is negative. That means overall your outputs would be negative. And then the last interval, I would need to test something to the left of -5. So something like -10 would be pretty easy to plug in. 5 times -10 would be -50. -50 plus 1, okay, so that would still be negative. 3 times -10 would be -30. -30 minus 2 would be -32. You don't care about the 32. All you care about is whether it was a positive chunk or a negative chunk. So here, when I plugged in a number that represented this leftmost subinterval, I got a negative from the left chunk, I get a negative from the right chunk, but if I were to have two negative numbers multiplying by each other, they would cancel, and overall you would get a positive. Right? So we're making this sign chart to see overall where's the graph positive, where's the graph negative. If you were thinking visually about the graph, everywhere to the right of 2/3 and then everywhere to the left of -1/5, the graph is positive. It would be above the x-axis. Everywhere in between the two x-intercepts, the output is negative, so the graph would be below the x-axis. Right? And here we were trying to figure out where is this graph positive. So this isn't the answer, but it's all the work that we need to get the answer. But the final answer is I have to collect all of the intervals, all of the values of x that satisfy this inequality. So I want all of the things that produce out positives, and only positives. I don't want the zeros because it's non-inclusive. Only want the positives. So this interval right here, right? Everything here is going to produce out a positive. We tested that earlier. So -infinity to -1/5. I would not want to include this. -1/5 produces out 0, which I don't want. So throw it out with the parentheses. I also wouldn't want anything in this interval because that produces out a negative value. I don't want this because it produces out 0. And then I would want everything here. So the union means and. So I'm collecting all these answers at the end. This interval gives you positive output, and this interval gives you positive outputs. So there's the answer. It's the intervals where the values of x, where this function is positive, where that graph is above the x-axis. The sign chart's all the work you need to do, but the sign chart itself is not the answer. It's how you get the answer. Alright, so hopefully that one kind of makes sense. I'm going to go ahead and just pause this video and then move on to the next one.